All right, good afternoon, ladies and gentlemen. When they asked me to moderate this session and they told me who was going to be speaking on it, I was excited to be working with some of my peers, if you will. And then I thought, this stinks. I don't have like a cool accent like the guys from Microtik or, some of the vendors from across the pond or something like that. Nobody's going to remember me. But that's fine because you're here to listen to these guys. So I guess what I wanted to get started on in this session is how many here are actually running a bridge network? Like 100% bridge, you have one router in your network and your head end. Okay, good. So this is a session for you. So the guys that are bridged, are you running Microtiks? Are you running switches? What are you running to create these bridge networks? Anybody? Really? So your routers are already there probably, just need to use them. Okay, great. So of those, I am assuming that everybody else is here for just more information because you're already running a routed network or some form of a routed network. Jimmy, you said you got a partially routed network. So anyway, with that being said, I'm going to let Dennis go ahead and come up and speak about his presentation, and then we're going to save our Q&A kind of to the end. So if you have some questions for these guys, if you think you need to, you're welcome to kind of stop them if it works. But let's try to keep most of the Q&A to the end. I think we're going to have plenty of time for that, and I think we'll have some good back and forth time. So without further ado, Mr. Dennis Burgess.
Thank you very much. All right, I am shorter, so I have to adjust the microphone a little bit here. Welcome, everybody. I hope everybody's having a great WISPA America. Had lunch. Everybody's full, tired, ready to go to sleep, right? No? A little bit? Okay. So, as he said, my name is Dennis Burgess. I'm the CTO with Link Technologies. We do advanced WISP consulting, technical support for Microtek, Juniper, Brocade, pretty much anything and everything. We have had experience with Linux servers, Windows servers, DNS. Again, we do try to do a little bit of everything. We have some customers that'll call us up and they'll say, hey, can you help us with an Aruba network? Yeah, we can try. We don't have any experience with it, but it can't be that complicated. So we tell them that up front, and usually we get it going for the customer. So today, I'm going to be talking about what makes a routed network and the different styles of routed networks that we have. I know we're going to probably have so many questions, especially on this topic. We're going to have lots of questions, so let's see if we can keep those down until we get through Justin's session, and we'll go from there. So the very first question is, what kind of network do you want? So right now you have a big bridge, and whenever I sit there and say a bridge network, I'm assuming that you have dumb switches. In other words, the switches are not manageable. I know plenty of customers that are like that. You have tower after tower after access point after access point. You're all sharing the same broadcast domain, and you have little to no firewalling or what I call protected ports on the network. So in other words, if somebody wishes to talk to another device on another tower, they just send an ARP, and they get that ARP, and now they can talk to it. So that is what I consider a big, ugly bridge network. Now, most bridge networks are usually fairly small. I do know several of them that can get kind of big, but eventually, especially if you're using unlicensed wireless gear, eventually that network's going to start performing bad. You're not going to have the best performance out of it, and eventually stuff's going to start breaking. So what I'm going to cover is several options, and these are not necessarily all of them, but they are just options, okay? So we're going to talk about BGP edges versus BGP internals, OSPF with an OSPF network, and then you add BGP to route your internals if you want to do that. That gets kind of complicated. We're not going to get too deep into that. You could just simply deploy a plain old OSPF network. Now, I do get a question, why do I always recommend OSPF? Well, most people in here are probably using Microtek, correct? Obviously, Cisco has several other software packages. I like to stay with open source packages that are readily available. And Microtek, pretty much the only thing it has, for the most part, for an IGP is OSPF. Are there other protocols that are smarter? The answer is depends on your definition of smarter. There are some that have a little bit more engineering behind them, but in many cases, OSPF is typically what most people will use. And then we're going to talk about OSPF plus MPLS. Then we're going to talk about OSPF plus MPLS plus VPLS. Yeah, that kind of gets a lot of pluses there. And then you also have BGP plus MPLS plus VPLS. Again, not all of these are good fits because you actually have to manage it. Now, how many people in here think that they want to go to a VPLS network? And why do you want to go to a VPLS network? Extended layer 2? So I'm just going to ask this question. I don't mean to pick on you. I apologize in advance. So you're going to break up your broadcast domain to just bridge it back together later. There you go. So typically, VPLS, there needs to be a business case for that. And VPLS, that is basically a layer 2 VPN or a layer 2 network that you can actually take from point A to point B and provide layer 2 services across your network. Most WISPs, not all WISPs, but most WISPs are not large enough to really need that service. However, some are. So that is probably one of the best reasons to do VPLS. So let's kind of get into some of these networks, as I said. So very first off, OSPF only. OSPF is extremely simple to deploy. You do require subnets at each location. If you wish to have router redundancy, and this is a really big thing, especially lately, that means you actually have 2 core routers, 2 edge routers, and 2 site routers. You can do that using OSPF. OSPF is very, very good at failover. And using Microtech, you can use VRRP to do virtual router redundancy to failover between each router. Again, this is a perfectly legitimate method of running. However, with OSPF only, you also have to take into consideration, are you going to be running V6? So if you are, then you have to run OSPF V3. You have to actually run a separate routing protocol. It may be OSPF still. Your settings can mirror OSPF, but it's a separate routing protocol. What's really nice about OSPF is it's very slick, it's very fast, it can be very fast. You can support multiple exit points. So if you get 100 meg over here, you get another gig over here, you get another gig over here, you can get your customers out to the internet as quickly as possible. You do not have to have a singular location for all traffic to come back to, and that gives you your multiple exit points. Something else that OSPF does quite well is it does OSPF load balancing. So you can actually take, again, a pair of links. I'm just going to pick, let's just say there are a pair of 100 meg links, and you can aggregate those. Now, if you do a speed test across those, are you going to see 200 meg? The answer is no. But as you have more and more client connections on there, you're going to see your 200 meg out of it. So you can OSPF load balance with that as well. And I have used that in some very odd situations, in which case it gets us by until we can get a new backhaul or until we can get our licensed radio in. So there are definite advantages to using just OSPF. Now, if you add MPLS on top of OSPF, again, this is pretty simple to deploy. It does require that you still have to require subnets at each location. You can have multiple exit paths on that. You can have multiple eBGP peers on several edges if you wish to. But by adding MPLS, you can, one, reduce your network view. So you can actually have a client go through your network and never see any hops from point A to point B if you wish to. Not saying you have to do that, but you can actually, there's actually a checkbox, propagate TTL, that you can actually check. It is a faster network. Now, when I say that in relation to Microtech, Microtech typically looks at the IP header to base its forwarding decision on. So if you're just using OSPF, it's just using the IP header. If you use MPLS, now you're only looking at this little bitty 4-byte header to decide on which direction it's going to forward. So in theory, you can have roughly 20 to 40 times more routing at the same cost. All right. Does that mean your packets are going to move through the network quicker? I typically say not necessarily, but you could have more packets as the network reaches peak load. All right. Next is OSPF plus MPLS plus VPLS. I'm going to get to a very key point here is that whenever you build a VPLS network, I manage several of them, it gets very, very, very complicated very quickly. I have a customer router, and I was actually going to put a slide in here, but I didn't, that it has well over 300 interfaces. You actually run VRRP, Virtual Router Redundancy, V4 and V6, on a bridge interface. That bridge interface has two VPLSs to the two edge routers that go out to the tower site. And then you have a separate core router that has the same exact features, except that's your backup site. Because with VPLS, you must have an exit point. Your IPs are all the way back at your NOC, or at your core, which is good because that allows you to spread your IPs and use your IPs more efficiently. But it does get very complicated to set up. Obviously, you get the advantages of MPLS when you do that. You're adding the VPLS tunneling, so you bring data back to your core. Now, whenever I do this, I always use pppoe. How many people in here use pppoe? How many people in here hate pppoe? All right. Can I ask? I know I've seen someone out there. Someone had their hand up when they said they hate pppoe. Why do you hate pppoe? Nobody?
Old to me.
It just feels old to me.
1995 called wants their routing protocol back, or their protocol back.
Nice.
MTU.
Right. So one of the issues is an MTU issue. I'll be honest with you, you really shouldn't have any MTU issues under normal operation. The big thing that we see is that typically with SonicWall, I don't mean to pick on them, but yes I am, they configure the SonicWall to only send 1500 byte packets, and they cannot be broken up, therefore they can't go through a tunneled interface. I like pppoe because one, it gives me a single point of instance for both V6 and V4. V6 and V4 work perfectly and flawlessly over a pppoe. Two, I can actually block everything else. So if I have a tower router and I'm bringing pppoe back to my NOC, I don't want to bring back ARPs. I don't want to bring back any protocol besides pppoe, besides the protocol I'm actually using. Otherwise, what would I need a VPLS network for? I can just run a bridge network and I can bring it back. I can just put VLANs on everything and I can bring all that data back just like that. That's probably the only time I would really use VPLS in those instances, with the exception of building tunnels if that's what you need. All right. OSPF plus BGP. Obviously, you can do OSPF. You can distribute your loopbacks. So you build your OSPF network. Your OSPF advertises your loopback addresses. And then you have a route reflector that talks BGP, and that's just iBGP, that then delivers all of your routing for all your public IPs. I have done this like twice. It definitely seems kind of hokey. It does work. I do know plenty of people that they swear by it. The other issue is you must have two route reflectors, because if your route reflector goes down, then your network basically goes down. You can get to all your loopbacks, but your loopbacks are not how all your public IP gets transit. So you definitely have to make sure that you have your BGP and redundancies involved in that style of network. The last one here is OSPF plus BGP plus MPLS plus VPLS. As far as your MTU issues go, even if you are doing pppoe and you are doing VPLS, you should have enough header space. You should allow enough header space to pass full 1500 byte frames. There's not a reason, especially with VPLS. The whole point of VPLS is so that you do not have to fragment packets and you can get larger than 1500 byte packets through. On one network we run a 9500 byte MTU. So for us to do pppoe, it's very easy. We actually just crank up the MTU. The packets, the 1500 byte packets come in, they get encapsulated, and yes, my packets are larger than 1500 bytes, but that's okay because my network allows that to transfer. And then whenever they come back to my NOC, we then disassemble the VPLS packet, we then disassemble the pppoe packet, and it's a full 1500 byte packet that comes back out. So there are ways around the MTU issue if you wish to run that. Again, I'm not sitting there stating that you have to run pppoe. However, in the current state of authentication systems that are out there, honestly, pppoe is pretty much my first choice if I can get the customer to go from there. So whenever you plan a network, now you kind of have an idea of here's all the different styles of networks. Again, this is a high-level overview. I guarantee we're going to have some questions. What do you actually need? The very first thing you need to do is you need to actually sit there and plan, what do you actually need out of your network? Do you need a 1500 byte MTU? Again, 99.9% of the time, the answer is no. 90% of your customers out there do not have to have a full 1500 byte MTU. You can fragment those, send it out, and they'll work just fine. It's usually an improperly configured web server, I have seen that, or an improperly configured VPN server that doesn't pass fragmented packets. So whenever you deliver the data to them, they pass back 1500 bytes and they say you can't fragment it, so then it can't go over your tunnel. So that's one thing. Then what do you want out of your network? What kind of performance levels do you want out of your network? What kind of network staff do you need to actually operate your network? That's the second question you need to have. And then the last one, just like whenever you do any of your planning, is what would be nice? What would you love it to do? What would be the greatest thing since cream cheese that you want your network to do? All right. Now, whenever I typically do bridge to router conversions, it's not as simple as that. I wish it was. But many migrations also come with, hey, we're going to change billing platforms. Or, my favorite, we're actually going to add a billing platform, and now we need to make a global change to our network that allows that billing platform to work, as well as we need to do a migration that we actually need to have some form of authentication. For those of you that are on the bridge networks, how do you turn off your customers? Do you actually have a billing system? Nobody? Okay, so you actually have a billing system? Okay. So when we look at those, we get a lot of them that they actually need a migration, and we also need to add authentication. So again, what options do you have? And this kind of goes back to my pppoe question. What options do you have whenever you wish to do that? Do you wish to deploy v4 only? Do you wish to deploy v6 only? That's a whole other issue. That brings up, now you have NAT64, 6-to-4 translations. Do you have enough public IPs for the plan that you wish to do? So if you're going to go fully routed, running OSPF at each tower, do you actually have enough IP space for you to give all of your customers a public IP? And then, whenever you do that, you might as well plan for V6, because V6 is here. I don't know if anybody didn't get the memo or not, but pretty much every major service runs V6 already. And if you are not deploying it, then your competition is. So my recommendation is that needs to be part of your migration strategy. If you're going through a bridge to router conversion, you should be deploying V6, and that brings up your authentication issues. When we get to hotspot, especially when we get to those hotspots, most of your hotspot systems don't even talk V6. There's no such thing as natting a V6 address and redirecting it. Not in Microtech anyway. Are there systems that can do that? Yes, there are, but they're not necessarily part of the current IP standards. So you need to make sure that whenever you are preparing your network and preparing your customers for that, to prepare them and to sit there and say, I'm going to deploy V6 and V4. I'm going to deploy this authentication method, etc. So kind of going through with what I just said, if you're doing V4 only, are you going to provide a public IP, or are you going to provide private IPs? Do you have enough IP space to take care of your customer base? V6, everybody in here as long as you have 100 meg for the most part, you can go get your own IPv6 right now. The requirements to get V6 is very, very small. So get it and deploy it. You really need to do that. And then when we look at a MAC address, MAC addresses are fine, but V6s don't really use MAC addresses anymore. They don't really send ARPs. So again, we have to make sure that if you're using DHCP, you need to have a authentication mechanism to be able to turn them off and turn them back on. Again, as I said, we don't really have a good way to do NAT64 in Microtech yet. I know it's coming, as they've said for many, many years. Yeah, he knows what I'm talking about.
Version 7.
Yeah, version 7. Yeah, there you go. But V6 is completely different. You need to make sure you plan accordingly for those. I have seen some other systems that use pieces of hardware that control data. That billing package, if you're going to use that, you need to make sure and tell them, hey, where's my V6 support? Because you need to make sure you have that. And if you don't push them, then they're not going to sit there and do it. They're not going to sit there and give you IPv6 support in those instances. I've also seen some systems now that they like to SSH into your router and make your router do all kinds of funky stuff. SSHing into the router is better than logging into your API on your router unsecured, but most people don't really want to turn on an SSL to make that API secure. So you need to make sure if you're going to use any of those methods, you need to make sure that you actually secure it because it is traversing the public internet. So, and especially with the API, like Microtech's API, if you are not running an SSL, then technically your username and password sit in clear text. Kind of really stinks security-wise. As I said, hotspots, at least in Microtech, there is no support for V6 yet. It does present non-paying customers with a self-service portal. That's also a very big portion of doing a bridge to route conversion is that you have to have a way for the customer to self-service. And then also, I do know some WISPs that they literally have a hotspot on everything, and if you want service, they'll go install a CPE, and then you can sign up through our hotspot page. I do know WISPs that do that, and it works for them. If that's what you wish to do, that's up to you. Again, I do recommend pppoe. You can do redirects. You can do self-servicing options. You can redirect a non-paying customer using pppoe. I understand there are MTU issues. However, 99.9% of the time, just with a little education and a little pre-planning, you can get around those, depending on how you design your network. Also, pppoe really load balances extremely well. We actually have a customer that has about 12,000 pppoe subs, and whenever they started maxing out their CPU, we dropped in another router, put it on that VLAN, and magically, about 50% of them migrated over. So it does work extremely well for load balancing. And as I said, you can block pppoe data, so you can actually sit there and allow only pppoe data through your tunnels, which is a very good thing to be able to do. Let's see here. Plus, this is actually another one. How many people here are static routed? Or I'm sorry, they actually put static IPs on their CPEs. And if you actually need to change something, you actually have to go to every CPE and make that change. Eventually, that right there is going to be it's going to be a pain in your butt because you're going to have to sit there and go to every CPE and make changes to them. I mean, what happens if you put Google DNS in and now all of a sudden you're natting all your customers. Now all of a sudden Google DNS is saying that you're getting too many requests from that IP, so they slow you down or they block you. Now you have to go change all your customers' DNS servers. You need to be able to make that very quick and efficiently. pppoe, you kick everybody off, you make the change, kick everybody off, they all come back on within 5-6 minutes, and they already have their changes pushed to them. So not saying that they may not have their pppoe or their DHCP or DNS server set up in their CPE or their device, but you can still push that data to them very quickly. Another configuration I have seen is EOIP. Believe it or not, it does work. During your migration, I have done this to where we build a routed network and then we EOIP it all back to the NOC so that they can finish their IP changes. I have done that as well. It does work. It does work quite well. It does add significant CPU load to your routers, but again, you're only going to be there for a week or two, hopefully, and that will hopefully really get them going quickly. So whenever I plan to build out a network or make this change, there is so many options and so many little intricacies that we need to know about your network. We need to know, hey, if you're going to do VPLS, what's the maximum MTU size that your network can support? Do you know? Most people, whenever they're coming through this type of class, they don't know that. And that's one of those things. I actually have to look at every piece of hardware that you're going through and find out what the maximum MTU setting is so that we know what we need to set our max MTU at. All right? Some devices, the max MTU is, 1579. Some of them are 9,000. Some of them are 9,500. You need to know which number that is, and you have to take the lowest that runs across your network, and that's what you have to set. So I typically say there's really too much to cover in a session, and I know we're going to get some really good questions, and I hope we really do, but I'm going to sit there and say that there's really too much to sit there and make a network plan for somebody in a class like this. But we do have some great case studies from Justin that we'll talk about as well. So with that said, Justin, that's my spiel.
Thanks, Dennis.
Yep.
All right, thanks, Dennis. So now, the man, the myth, the legend, you all know him by his voice, Mr. Justin Wilson.
That one yours or that one? This one's mine. Okay.
All right. My name's Justin Wilson. Pretty much everything you want to know about me, my current website address, j2sw.com. We're doing a lot of peering, interconnect, stuff like that. Ask me about that sort of thing. So anybody that's talked to me for very long knows any kind of network planning, anything like that is almost a philosophical approach. So kind of like what Dennis was saying, there's all kinds of ways to skin this cat, whatever analogy you want to do. So, some of the things I'm going to tell you are from my perspective, and you might have your own variations on it, or you may have seen something, work a little different. That's not necessarily wrong. You might ask a bunch of network engineers how to do something, and you might get 20 different answers, and they might all be right. So let's do some misconceptions. I had a client call me the other day, and they were all concerned about their backhauls were a bridge network because they've been saying, I'm running this bridge network and I don't need to be running a bridge network. So one of my questions, is this a bridge network? We have routers on both sides and we have a couple backhauls in between them. And yes and no. The backhauls are bridges, but this is a routed segment. We have routers on both sides that contain the broadcast domain. So, just because you have some devices that are bridges, that's all right. So I wanted to kind of get that out of the way. So I hear this a lot. Routing is complicated. I'll lose speed with routing. I'll get to it eventually. I can just throw up a bridge and I can get access to my neighbor, or I can get access to the next town over. So I don't want any of you to leave here and think, oh, this is such a monumental task. I can't do this. I want you guys to go back to your rooms and be sketching diagrams, and I can go home and I can do this. I might need some help, or hey, I can do this my own, or whatever. But I want you guys to, I can do this. Stop us in the hallway, buy us a beer, whatever. I'll be glad to talk to you about, whatever. Yeah, G.I. Joes. Brian down there, thank you, Brian. Brian brought me a G.I. Joe. I'm a huge G.I. Joe collector. So let's dispel this myth. Routing is complicated. You heard Dennis talk about MPLS, VPLS, all this, this alphabet soup. You don't have to do all that from day one. If you're running a bridge network, Your goal is to route that network, whether it be OSPF or whatever fits your bill. So you can grow into MPLS, you can grow into VPLS, you can grow into all of this stuff. I'll get to it eventually. No, you won't. Just face facts here. Human nature says we'll get to it if we hit the brick wall. So everybody does. I'm a fat kid. It's taken me a long time to lose some weight, and I've just been doing it. So, but for years I'm like, I need to do this. I need to do this. We do this with everything. So how many of you have to-do lists as long as your arm? And bridge the routed is probably on that list. So set aside time before it becomes an issue. I see this over and over. Someone comes to me, man, I got this ARP storm. It's taken down all my customers. I got a customer who's plugging in routers backwards and they're handing out DHCP to my customers, and it's taken down my whole network. Do it for the sake of your network. I'll lose speed. Buy quality hardware. Good network design will fix this too. And in the immortal words of my friend Tom Smith, buy bigger routers. Throw hardware at it. This isn't the 1990s where a Cisco router costs $20,000. Well, it still does, but you have large processors in these routers today. You can throw horsepower at them. So where do I start? That's why you guys are here. So it all starts with discovery. I have people come to me and they don't know what they have in their network. They don't know, they've gone through lots of installers, a couple network techs, they don't know what the equipment is out there, kind of like what Dennis was saying. You need to take an inventory of your network. What switches do I have out there? Because you may run into MTU issues. Hey, I decided I want to put 1600 byte MTUs on my whole network. Oh darn, I got a device in here that only supports 1597 or whatever it is. That's going to throw a wrench in my plans. So know where your stuff is. Know where your customers are. Know who your customers are. Know what you have installed. It's amazing how many people have just put up customers because it's easy. Hey, I just pointed at the tower, it gets a DHCP address from somewhere, and they're online, and I just kind of forget about them. So, that's a whole nother story about keeping records and stuff like that, but plan it out on paper first. Get out the crayons, draw out, oh, I forgot I had this little one-off connection I did for somebody. Because there's nothing like getting halfway through a configuration and you knock somebody offline because you forgot about them. So in my mind, one of the key things is your IP plan. How am I going to lay out these IPs for this bridge to routed network? I need IPs for all these devices, infrastructure, customer pools. Am I handing out public versus private addresses? Am I doing IPv4 versus IPv6? Backhauls, access points. If you're running Cambium devices and you're running CMMs, I got to have IPs for those, so I got to count for those in my IP plan. So I need to count for growth as well. So we'll talk about a couple, kind of little case studies we did. So then you're kind of talking about some things like carrier grade NAT. Am I going to implement some carrier grade NAT in my network? Does my equipment support everything? Does it support IPv6? Does it support those large MTUs? And here's one thing I see a lot of folks do when it comes to private IP space. We don't run out of private IP space. You have to work pretty hard on a network to run out of private IP space. So when you're going through this plan, be generous with your IP space. And think about it from an expansion point of view. and a business point of view. How many customers or how many people in this network think you're going to grow beyond 250 towers in your network? Okay, you maybe, okay. So you're in a little bit different ball game. But realistically, if we all had 250 towers, we'd probably be driving Ferraris and we'd be happy, right? So be realistic. I've seen people say, hey, I'm going to conserve this IP space. How many towers are you realistically going to get? Let's multiply that by 10. So just I'm a realist, so think of some things like that. So when we come in, we don't try to salvage the old IP scheme. It's more work to try to figure out what somebody else did, what the guy 2 generations before did. I've seen too many plans get bogged down trying to understand what's going on. In today's way of, at least the way I approach things, you can cookie cutter enough design where, hey, I've already done this before. So when I come into a network, I've already invented the wheel. So here's the wheel. We just have to apply it to your network. So in that case, we can run this bridge network and this routed network side by side as a transition. So, it's a very process-driven approach. And we'll get to that in one of these examples. This will all tie together, I promise. So if we do it the way I like to do it, it's not an all or nothing approach. You can switch some customers over today. You can go to the beach tomorrow. You can switch some more customers over the next day. It allows for allocation of resources. Not only techs can be on call because you're going to have customers that may need to reboot routers, the clear ARP tables, stuff like that. And it's easily duplicable across your entire network. So you want something that not only fixes your current problem, but also, if I add this new tower, I just have to drop this solution in. So, and one of the biggest things with doing a cookie cutter solution is it's easily to be troubleshooted. If it's all the same and everything's pretty much the same IPs across the board with maybe a couple changes, people can learn that easy. So let's look at a case study, and this will kind of bring this all together. So here's a little ISP. They had 12 broadcast sites, mainly 2, 4, 5, 8 at each site. They had about 300 customers, and every CPE was in router mode. This was ubiquity equipment. So the CPE was getting an IP from the ISP and then turning around and handing DHCP to the customer. So typical problems with bridge networks. They're getting broadcast storms on the network. All these 300 customers share the same physical wire, so to speak. They all can see each other. They can all jabber each other. They can all talk. Redundancy was an issue. There's no way to switch links. So this ISP, their idea of redundancy is they had some redundant backhauls, but if one of them went down, what the ISP did is they got in their car, they drove out to one of the tower sites, and they flip-flopped cables. That's not very efficient. So, and it makes troubleshooting, a big pain. So here's what we did. So we came in and we did a /21 of private IP space. For our first power, 10.0.1.0/21. We dropped that at the first tower, and we just duplicated that across all 12 of their towers. And this is kind of how we broke it down. So if you break it down into manageable blocks, we went through that list that I showed earlier. We addressed the APs. We addressed any UPSs. We addressed CPE. I won't go into the customers because that's a whole debate, public versus private. You know, some people have enough publics to do this, some people have enough privates, most people don't have enough, so it becomes a hybrid. So, you know, every CPE has to have an IP on the network. So here's how their network first looked. They have a router at the core, you know, router over here, and it's handing out 192.168.10.0/24 to most of their customers. When they ran out of that 24, they added another subnet. So everybody was getting essentially every 10 dot something address. Their APs, their backhauls, their customers, they were all on this subnet. So like I said earlier, everybody can see everybody. They all go back to the edge router to do NAT. So stage 2, I call this pseudo routing because this does not require a single bit of hardware. You don't have to go out and replace a single thing. We've not made any switch changes. We've not added a single piece of hardware. So what we did is we added a 21 to each tower. So we designated a 21 for each tower. And we broke it up. If we go back here, we broke it up following our scheme. We broke it up and we added all of these IPs to the bridged interface on the edge router. So that way, when we go down here, say there's an AP here, we can change that AP to the new scheme and it comes back here to talk. So that's how we can talk to the AP. Everybody kind of follow along, and you're more than glad to come up and ask questions when we get through this and everything, and I'll gladly, you know, hey, how's your network work? So we're still in the same layer 2 network though. We haven't added any routers or anything. Our idea here is we're preparing to drop routers in. So we're pseudo routing this network. We're logically separating our customers into towers, but we're still on the same physical wire. Now why are we doing this? Because when we get to our stage 3, which I did this morning after no sleep, so that should say stage 3. When we get to the point where we're like, hey, we need to add a router here instead of a switch. So we can go out ahead of time and we can add a router in place of a switch, and we can put that router in a bridge mode, but it's a router. You know, if everybody's using MikroTik, you're familiar, you can bridge all your ports together. So we drop that in, now it's a managed switch. We can talk to it. So now, say one night, one morning, whenever, we can say, hey, we're gonna route this tower over here. So what do? We come in here and we take the IPs that we had over here and we move them to ports on this router. So we take ports out of our bridge and we make them into routed ports. So now we've moved where all of these clients, APs, everything like that, we move where they talk. Instead of going all the way back here to the edge, they're talking to a local router. Okay, so you can do that that's the only hard cutover part of this process, because you've actually now physically changed how the device works. Instead of it, yes sir?
But the bottom address will get 10.1.8/30 and the other /1.
Yes.
It could be like an 18.
So, well, the 10.1.8 goes back to our first AP.
Right.
So in my design, or in this customer's design, we say they have 2 APs on the tower. We have a router port and we have an AP. So that's how they talk. So the router is .1 out of that /30, and the AP is .2. Because all we need to do is talk to that AP for management.
Right. The other tower, though, looks like you have 2 separate subnets. Down the bottom, looks like the same subnet with 2 different names.
Yep, so this one here, That's just one AP. That's our first AP, the /30.
And the other subnet is 10.1.1.
Yes, this one is for our CPE.
Okay, but down on the bottom, that's the same,
That's the same thing for a different tower. Yep.
but it's in the same range, is what I'm saying. 10.1.80, 10.1.80, 25 to 30.
But if we break up our 21, if we run our 21 through a subnet calculator, our 10.1.8, our boundary is 7.255. So our next 21 starts at 8. That makes sense? So in this scenario, all we've done is when we've added the routers and we've enabled our router ports, we're just moving those IPs. We've already gone through, we've changed AP addresses, we've changed CPE addresses, we've gone to any authentication we want to do, any of that stuff. We just simply move it from the edge to the new router, and bang, they come up on the new router. So, some of this is philosophy. You can change that up. You don't have to do 21s, all kinds of things. You could use a managed layer 3 switch to do the same thing, Yep.
Is it assumed you're doing DHCP, or is that statically done?
That's assuming you're doing something dynamically. You're already touching the customers, so you might as well do something dynamically.
Would you move the DHCP server from that one to those two there?
Yeah, if I'm doing DHCP, yes. Yeah, if I'm doing DHCP in this sort of a scenario, I have a DHCP server here, and then when I go to this model, I just move my DHCP server here. So with the 21, for this particular customer, each AP we allocated a /25, which is over 100 CPE per AP. So if you got 3 APs, you still got enough IP space to do, 100 customers per AP. And if you're thinking, well, I have one client, he's got 10 or 15 APs per tower. So instead of doing a 21, we did a /16. So, this is part of the philosophy thing. We could have used 172 something addresses instead of 10 dots. We could assign more IP space to the tower. We could have done VLANs, like Dennis said in his slide. We could talk all day on different things. How are we doing on time?
About 10 more minutes.
Okay, I won't really, the only thing I want to talk about on this particular network is the sheer number of customers. This is an all bridge network. So I'm not saying that do this, but your bridge network can survive until you can make it routed. So this particular customer is an all Cambium customer, so he can do a lot of filtering at the subscriber level. He's got 1,300 customers in an all bridged network. Yeah. Yeah. Say what? They're all bridged. All the subscriber units have the same exact IP. So if anybody's been around Cambium for a while, and when it was Motorola, they said you do all your management through the AP. That was the old way of doing stuff. So he's in the process of going bridge to routed, but he's doing it at his leisure. So, this is just kind of what he's doing, some filtering. Clients are doing triple PoE. This is a perfect example of how triple PoE is saving his network. Without triple PoE, this network would be crashing and burning on a daily basis. So, I just want to sum up, start with a good IP plan. You can change IPs on APs and SMs without affecting any customer traffic. Pseudo route everything, and then you can install routers. Love it when a plan comes together. So you guys can do this. You need to do it. Dennis touched on MPLS, so we won't go that. One thing you do hear, though, is anybody doing data centers, it is kind of doing the opposite. The data center fabric is collapsing from layer 3 down to layer 2. So if you hear that, don't let that scare you. I still need to route. Some things to help you along the way. PHP IPAM is a good keep track of your subnets. IP plan, they now call it IP track, is the old school granddaddy of them all. It helps for things just like what you're running into. You know, you looked at the subnet, well, that doesn't exactly match up. Well, IP plan can do all the thinking for you. So that's me. Questions?
Thanks, Justin. I appreciate that. So yeah, anybody got any questions right off the bat? Go
We,
ahead.
we do need you to come up to the microphone.
Oh yes,
As
please.
this
If
session
you would.
is being
I know
recorded,
it stinks,
so-
but if you'd come up to the microphone, that'd be good.
Yep.
Suddenly, all the questions just went away, right?
Yeah.
I just want to go right back to what you just said about the data center fabric collapsing. Could you expand on that a little bit?
So data centers are going to we want data to go at, you know, fiber channel, SAN, all that sort of thing. Cores are collapsing. Cisco used to have the three core design. They've kind of collapsed that into a 2-core design, where between your different layers of the core, your edge, your core, they're combining those into a layer 2 fabric. Depending on the design, you know, some of it is MPLS. Some of it is strict, Ether channel, Trill, even IgniteNet here, who's at the show. Some of their products are supporting Trill. Fabric Pass, another, you know, it's been around for a little bit. It's kind of faltering. Can you think of any of the other? There's Trill and VXLAN. VXLAN's a big up and coming in the data center world. So they're going away from layer 3.
Routing, yeah.
Yeah, a little.
Even though they are going away from layer 3 routing, the big difference is, one, they have switches that can pass billions of packets per second. And that's the big difference whenever we get into from a bridged wireless LAN. You know, back whenever I started, if we had 5,000 packets per second across a bridge, it would fail. And that's one of the reasons why we need routing versus a data center. You got these big switches that can handle absolutely massive amounts of data, and they don't really care. They don't even slow down.
And shameless plug at 3:45. The next session is literally about redundancy in the core. I'm actually doing a presentation on redundancy in the core, and our core specifically uses switches that run Trill. And there's various ways of doing that. So if anybody's interested in that, you'll probably want to hit up that next session. Yes. Well, it's in the, I forget what room it's in, but it's right down the hall. Go ahead. Who's next?
Yeah. How do VLANs in relation to the process that you just laid out, how can VLANs do the same thing but at just one step instead of, you know, you like have a physical router here, here, and here. Can we just start with a VLAN back here, push the subnet out to a site, and then VLAN 2, 3, 4 on down the road? Just want to know how that relates and if that can work the same way.
Yeah, VLANs can work the same way. It adds an extra thing to keep track of, because now you have an extra interface and you have to make sure you carry the VLAN all the way through the network. So if you're, you know, say you're doing VLAN 10 out to tower site 5, that's essentially 3 hops away. You have to make sure that you can carry VLAN 10, you know, all the way through. You know, that's one of the things MPLS kind of takes care of. MPLS negates, VLANs and that sort of a deal. But it is possible. It is possible to do VLANs at the tower level. So, you know, every AP could be a VLAN. So, you know, you run a triple PoE server on the VLAN, you know, that sort of thing. I'm sure Dennis has some.
So I will sit there and tell you this, is that if you're wanting to run VLANs to segment traffic, that does not necessarily mean, and also it does not necessarily isolate all of your traffic. I will use this as an example. If I have two VLANs and one VLAN has a bridge loop running in it, running across the same backhaul, does my backhaul go down? The answer is it goes down. So I do not consider VLANs a alternative to proper routing techniques. There are plenty of places for VLANs, and again, if you had the data center with a switch running from point A to point B, it wouldn't hurt nothing because you got so much capacity there, you're fine. But in this particular instance, again, going across unlicensed backhaul, you don't have the capacity to withstand that traffic.
So at one point, I moved over to, I'm kind of in like the pseudo routing phase, I think, but I don't know how effective it actually is because like I went from the bridge where they're all basically one interface, then segregating them out into each interface, DHCP server on each one, but then I just added static routes to each interface, so to speak, just so it can know where to go. Does that actually give me any benefit from that, or am I just segregating subnets at this point?
Right now, you're basically you're logically splitting your traffic, but you're not seeing any of the benefits because you have not broke the bridges.
And I've not added any routing protocols to it either.
Correct. So you are going in the right direction. You just haven't finished that last step of actually breaking the bridges and gaining the resources that you normally would gain from that.
So how are you guys handling quality of service and packet prioritization through, VPLS and then also through pppoe? It's easy enough to do through DHCP, but how are you handling it with the other two protocols?
So in my instance, I don't. I go back to the net neutrality thing. All packets are created equal. As long as you have a quality network that is not oversubscribed, you should not need any type of QoE or QoS on top of that. However, your DSCP bit, it can still be honored. And especially through MPLS, Microtech has a way to peer into pppoe packets as it passes through a router. And therefore, as long as it's not encrypted anyway, which your pppoe should not be encrypted, never encrypt your pppoe, FYI, it should be able to honor any of those DSCP packets that may be on your IP packets. So there you go.
Something else I wanted to ask. So we have got our main office with the black backhauls there, and it's serving a small area there. But then, at a separate tower, we're not beaming it to that tower. It's actually a separate backhaul that we've purchased. So, assuming that, that's only one exit out to the network at that point. So, would adding a routing protocol actually help that? Would it improve quality at all, or is that just?
No. So you have two towers, and you're asking if you adding a routing protocol will make any difference versus static routing. The answer is no, it's not going to. The routing protocol is there to help you with automatic failover. Right. So if you have two backhauls going from point A to point B, you can have a primary, and then if the primary goes down, you can fail to the secondary. Yep.
How about another 3 or 4 minutes for questions?
The configuration I saw was more of a spoken wheel kind of configuration. We have a lot of our towers we got 3 towers behind 1 tower, and so that becomes a little bit more complicated. So how do you deal with that?
So I just did that as a, just basic, help you understand it. So what you can do in that is you have your edge up here, and so you start at the furthest away tower. So when you pseudo route everything, you get all your IPs changed, all of that. So now your network is running on this new IP scheme. Customers have new IPs, APs have new IPs, all of this. So then when you go to switch them to routed ports, you start at the furthest away, because that way you're not having to route through stuff. It's easier. You don't have to add static routes to be able to get to something through a router. You just start at the very edge. So that way they still have that layer 2 connection back to your edge router. So then you do that one, and then you start moving inward back to your edge. And I touched on this, you will have subnets in between the routers, because that's how the routers talk to each other. You'll have backhaul subnets in between those two. So when you do your first tower and you're ready to do your second tower, those two will, if you're doing OSPF, they will establish an OSPF connection. Those two will exchange their routes, and then your router up here that is still bridged back to your core, it knows, hey, I can get to this guy over here, but I'm still on the bridge network. So your edge router knows where to go through the dynamic routing protocol, even though you still got bridging going on. So you don't start in the middle, you start at the far edge and work your way in. So by the time you get close to the edge, everything else is routed. Yeah, sit down with me and I'll show you.
Yeah, hit these guys up. That's why we're all here, it's to share information. So hit them up, buy them a beer, whatever. Sit down and kind of hash something out. These do what?
I like scotch.
There you go, scotch. They're here to help you guys. They can also help you once you leave here. That's what these guys do for a living, and they're incredibly good at it. I think we're probably about out of time for questions. Like I said, we're having a network redundancy talk in the next room down. I don't remember what it is now, G or H, something like that. And it's at 3:45. So if you guys want to join that, we'll see you then. Thanks.
Thank you.